Howdy, everybody. I'm here for day 5 of Advent of Code. So far, I've been having fun, and I had a lot of time to do a little refactoring today of day 4, so I thought I'd just show you what that looks like before we get into day 5. Let's see. So it started with me updating these pointers. I don't know if you remember, but there were a couple places where we do like some point arithmetic. Um, like right here. And I used to have a lot of, and right here, I used to have like a lot of like parentheses and references and dereferences to there. So I just spent a little bit of time fixing those up. The way these operator like overloading functions work is like you specify like what you want on each side, right? The left hand side and the right hand side. Um, and then you just have to make sure you have the output correct, right? So this is the right hand side and this is the left hand side. And so you can see I've actually implemented it both ways, like a reference on the right and then a reference on the left and then a reference on the right. And they return different things, right? Well, I technically they return the same thing in this case, but and you'll actually look if you look in the standard library source code, they do this as well for many of the types that use these overloaded operators, um, and they do it even at like multiple levels of references and stuff like that. And the reason is because it like simplifies the way the code looks. So I just spent a little bit of time getting it right, getting my the correct which ones are references and which ones are not. The same thing for multiply to like what am I doing with pointers and subtraction. I just looked how I were using it. I was using them and implemented them the ways that were necessary. So I only had to do it 4 times here for the point type. But you know, if you're I just thought this was interesting to bring up because if you're doing something like creating a library or you have some types and you want to be update and you want to use some of these overloaded operators, sometimes it's a good idea to implement add for multiple ways with multiple references so you can get all that stuff and then you don't have to do the dereferencing and stuff like that. Okay, so then I just one of the things I like about Rust is the ability to like do the functional programming. Um, and the and A previous comment even mentioned like how come your code is smaller and faster. The interesting part of like this functional programming is the compiler does a really good job of making this really fast. So I actually went through and you'll see some changes I made to be make it more functional, just because I enjoy trying to do the functional part of it. You don't have to do the functional programming. You're welcome to use for loops, and the compiler will often help you with those too. Sometimes the gains are minimal. Excuse me, the gains are minimal enough that it just doesn't matter. So you will notice, like when I'm create, so I stuck with the grid type or the graph type solution, and you'll notice here instead of using like an enumerate, I'm using a zip. That's because our point is an I size, just so we can have those negative numbers that fail to find. Right? We don't have a negative number in the graph, but we have those negative numbers fail to find. So I use a zip here to do so that we can get I sizes. Excuse me, and then that allows me to do collect my hash map pretty easily using flat map. Nothing there. The neighbors I changed. There was a great comment from the previous day about using ItterTools Cartesian product. And so that allowed me to, you can see I'm just iterating over the, you know, -1 to 1 inclusive, um, 2 ways. And then I do the Cartesian product of that. And then I just filter, I can just use filter to filter out like the middle one, which is where I actually am. But then now I can use like very functional solutions. So I can do a map, a filter, and a collect. And you can see this is uh, probably a third of the lines of code that I had before, and it's more functional. So I really like that. I think it looks cool. So this Cartesian product was a good function to come out of ItterTools that kind of helped me to do that. Right, simplified that. Let's see. Okay, and then in for the two parts, I decided to move it into like a more functional style. So you'll actually see I am doing an iter here, and then I filter by X. The actual logic doesn't change. It's just I've gone from like nested for loops to using functional like style methods. And so you can see here we just say go through the grid, find any of the X's, and then for each of those X's, I'm going to do a count of all of the times that the neighbors have an M. So the neighbors of X have an M, and where in that same direction there's an A and an S. And so I clean this code up a little bit. You can see like once I have an X and then I have an M, I know what direction I'm going. That's the delta here. I probably change that to like direction. So once I have a direction I know I'm going, I can just say, hey, go 2 times that direction and then 3 times that direction from the given point that I'm at. And then I can get those two values. And if they're A and S, then I have found one. If they're not, then I haven't. And so because I can do this like this map, or sorry, these two filters, I just get a count of how many times I find the MAS around the X going in the same direction, and then I just sum up those counts. And so that gives me the solution to part one. Part two, I also cleaned up. You can see it's almost smaller than part one. So part two, again, if you remember, we were just looking for like an A and then like MAS along the diagonals. And I'd made the mistake of trying to find the cross as well. So I clean this up a little bit, but again, we can use the functional programming to filter and look for all the A's, and then once we found the A's, we just I kind of did some simple gets right here to say, hey, what's in the top left, top right, bottom left, and bottom right, and this felt like it was cleaner. I mean, it's probably technically more lines of code. You could squash all these in here, but this felt like it was more readable to say, hey, what are the corners around the A? And then do I have an S and M or an M and S going this way? And then do I have an S and M or M and S going the other way? And if I do, I add that to my count, right? In this case, I don't have multiple counts. Like the way the X works is you'd only ever find it once per A. So I can just count all of the times that I found one of these, and then I'm done. So that's it. That's it for day 4. Those are the changes I made. I think it's a lot cleaner. In the end of it's more code, but I think it's more readable code, right? So a lot of the code is up here doing these adding these operators to the point that make it more readable. Um but it makes it feel cleaner, at least from my point of view. So I updated that stuff. You should be able to see it in the new gist if you want. So, given that, let's start with day 5. I kind of tried to get this stuff ready. So, we have all that. And then let's just look at day 5. Satisfied with their search on series, the squadron of scholars suggests subsequently scanning the stationary stacks of Sub Basement 17. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. Okay, so I don't necessarily remember this one. It looks like I have solved it before, though. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed. So you offer your services. Safety protocols clearly indicate that the new pages for the safety manuals must be printed in a very specific order. The notation X bar Y means that if page number X and page number Y are to be produced as part of an update, page X must be printed at some point before page Y. Okay. So they're not necessarily next to each other, but they must be in this order. The elf has for you both the page ordering rules and the pages to produce each update, your puzzle input, but can't figure out whether each update has the pages in the right order. For example, so here's a bunch of rules, and then we get a double new line and some comments. So these are the pages to produce. Okay, so these are a bunch of rules that say they have to be in this order. So 97 has to go before 13, 61, and 47. And 75. I was kind of wondering if it creates kind of like a graph. It probably does. Here's another 97. But it looks like, for example, 97 branches multiple times. So it's not like, at least in this case, it's not like a linear graph. It's a very, very explosive graph, probably. Yeah, you can see there's multiple 61s as well. Okay. So there's definitely like some interloping or some like interleaving between them. That'll be interesting. Anyway, the first section specifies the page ordering rules, one per line. The first rule, 4753, means that if an update includes both page numbers 47 and 53, then page number 47 must be printed at some point before page number 53. 47 does not necessarily need to be immediately before 53. Other pages are allowed to be between them. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update means that the update consists of the page numbers 75, 47, 61, 53, and 29. To get the printers going as soon as possible, start by identifying which updates are already in the right order. In the above example, this one is in the right order. Yeah, so there's a bunch of 75 rules that say it has to come first. 47 is second. And then 47 has rules that say these have to come after it. Okay, so basically, you do like some of these checks to say, are these all in the correct order? The second and third updates are also in the correct order according to the rules, like the first update. The fourth update is not in the correct order. It would print 75 before 97, which violates this rule. The fifth, 29, and 13 are off. So there's a rule here that says 29 comes before 13. That's not the case. The last update is not correct due to breaking several rules. Okay, well, we won't look at it, but presumably anytime it breaks a rule. So you could think of creating like a kind of a hash of like all the ones that 97 have to go over after and like brute forcing it and just saying, okay, I'm here and I know that these numbers have to go after it. So are there any numbers that go before it? Any of them that go before me? The elves also need to know the middle page number of each update being printed because you are currently only printing the correctly ordered updates. You'll need to find the middle page number of each correctly ordered. Okay, so the middle one. And then we're going to add those together to get some score of all the ones that are correct. Okay, how many rules are there? There are a lot. But it's not a ton. I mean, again, I think we're well under the 1,000 range, which means that brute force could be okay. Yeah, like in total, we've got relatively few. I mean, again, this is one of these days where because it's small enough, brute force is probably an okay start. Like we could start thinking about generating a graph of these and looking at the graph and like seeing if there's a pattern if the brute force doesn't work. We could also like let's see if we built a graph of this. Could we step through these items, right? So like imagine we have a graph. Like I'm wondering if that would work or not. Let's try Microsoft's whiteboard and see if I can't kind of reason about it. Is my thing working? Oh, but it's on the wrong side. Where's that tablet thing? Working area. This one. There we go. Okay, so let's say we have. I mean, I guess I'll just start drawing. Well, this is not very good, is it? Oh, is it because I'm hitting something? No. So I've got like what I'm thinking is how would you know like if we know 90 97. Wow, this is really not working. Has to go before 3. What's happening here? 5 and 7 or whatever. And then there's like a 1, 2. Well, I don't know. I don't know why that's happening when I use the whiteboard. Maybe I just unplug it and replug it in. Have you tried turning it off and on again? Oh, I mean that may have actually fixed it. Okay, so if you imagine like the sequence like 97, 3, 5, 4, 2, like this is a valid sequence, but like how do you traverse the graph? I mean, maybe it's like in layers like this. But that doesn't even work because I mean, I don't know how these look, but it'd be like 97. It could be like 97 3 2 5 4 7 1. And then that works as well, right? So you can't it's not like what I was thinking is I wonder if the numbers allow you to do like a traversal that say, "Oh, I can definitely go here and then I can do these ones, or I can go here and I can go here and here and that's okay." Um because I didn't use this. You could also do like is it something about the depth? Like 97 is the highest, and then 7, 5, and 3, and then 1, 4, 2. Like these are like the layers. And so like you know that so this is layer 0, 1, and 2. Um if you know if once you get a number in layer 0, what would the rule be? Once you get a number in layer 1 and you go down to layer 2, you can't go back up to layer 1. That doesn't actually, yeah, see, that still doesn't work because you can go 97.5, 4, but then you can also go 3, 2 and go back up. So there is definitely like some directionality to this, right? Hmm. I mean, let's just try brute forcing it and see if it doesn't work. I know no one likes to do the brute force, but I can't. Nothing is specifically like no graph algorithms are coming to mind. That would be like, oh, here's the graph algorithm you should use to do this. And maybe it's just not a graph algorithm. We'll go look. Maybe I missed something. I'll zoom in a little bit, see if that doesn't help. So we'll let the rules equal. How do I do this? Let parts equal. We definitely want a map, and we want to be like we want to split by bar. Oh, this needs to be mutable. Okay, so we'll get the rules by just. I mean, this looks pretty ugly, but we can try and fix it later. We'll split the input by double new line, which will be this right here, and then we'll then get the lines of the first part and split them up to give us the rules. And then we'll let the pages equal this. We are going to have to parse them. Is that the correct way to do it? It's going to be a vec usize. Yeah, that's fine. Okay. Parts next. Oh, what is it? Unwrap. It wants to be the same, right? I don't know why. We're going to do the same thing for the left and right. We're going to have two numbers on each side of this one. And then why doesn't it like this one? Just syntax errors. Okay. I did update it so it auto formats on save, which is what NeoVim used to do for me. Okay, so now I have the rules and the pages. So what is the brute force approach to this? When I see the number 75, I want to go find all the 75s on the left-hand side, and I want to say each of the numbers that are on the right-hand side can't come before it. So I actually think I want a hash map here. Um, how do I build this hash map? Join. Mm, I mean, it wouldn't be a collect. It would be a reduce. Am I thinking about the wrong one? Accumulator. Fold. It's going to be like match act dot entry key, or what is it? Oh, you can do it in one line. We can just do entry dot or default plus equals dot in push, right? Like that. So it's going to be a u size back u size. I'm pretty sure I did that wrong. It's right here. Nope, it's not there either. Where is it? Does that help? Yeah. Okay, so this was a lot of. Hopefully, I didn't mumble. I'm really trying not to mumble. It's weird. I'll try and be better about that. But what I really want here on the left hand side is or I want a hash map, right, where I can say, hey, I'm at 75. I want to go look back and see if all the ones that are 75 or if there's any that are before it. Um, So I think I can do that with this. So we do basically we get the first chunk, we map it to the left and right integers, and then we fold into a hash map. And then for the pages, we're just going to get a list of pages. And we want to, eventually we're pulling out the middle element. We'll do that in a second, though. So, it thinks we need a cache. Okay, that'll be interesting. So we're going to have a page. And then basically we're going to say let I equals 0. So we're going to, where are we in the page? And then we're going to say, what are the ones before? Or expect after. I want to do that inside a for loop, right? So for each, what are these called? For each, and then each pages in page, and then we'll do for page. We'll do I page in pages enumerate like that. And rules.get will be for the page. So we'll get the rules that have to come before it. Right? So we say iterate through all the updates. Iterate through all the pages. Get the pages that must go after this page is there. And then we say go through all the pages before and make sure none are in the expect after. So we want to break up here if we do that. But if we happen to get through all of them, then we can do P1 like that, and then we print P1. Okay. 12. Rolling 12. Well, that's interesting. Why would that be the case? Oh, there's an empty new line at the end. Is that right? Yeah, it's doing the new line at the end. So like that. No. Trimming not work. Ooh. Is this like a weird Windows thing? No, still do not have it. Okay, what's going on here? Oh, no, no. Now I get to line 25. Okay, so now it splits properly. So this one is not right. It doesn't like this one. Line 25 when I do a map. Invalid digit. It's not split white space. It's comma. Okay, this would be the case if there's no rule. Let me clean up this stuff a little bit. Um, like if there is no rule for the specific number, then we just move on. can't be right because I'm just adding. Test.text. How am I even getting 17? It's only down here that I do it. Yeah, it's actually, this should be the outer one, right? Like if I fail anywhere in this iter, I should fail outer here and skip this part. It's only if I go through all the pages and all of them are good, then do I go here. Otherwise, I continue to outer. So this isn't actually going to be the correct number. But it should say the first and second are correct. So it is only 3. So now I just need to get the middle one of it. Like that. 143. Yeah. Okay, should we try with the input? See how long it takes? Not long. Hopefully it's correct though. I mean, it has to be correct because that's the. I'm literally just brute forcing it, so I haven't found anything interesting. Is there like a split lines? Oh no no no. I'm not doing lines. I want to split by this. This is really ugly. It feels weird to have to do this. Let's see. Okay, well, why doesn't that work then? I don't know if you guys could hear my Google respond to that. Yeah, why doesn't it like that? Anyway, well, I'll have to look at it in a second. Let's move on to part 2. It seems to suggest that this just works magically. Okay, hold on one second. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the okay, I mean, I guess that's use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. So this one becomes this one. Okay. Can we just do the same thing? if we, I mean, the same thing in that we still just brute force, like, go through them. If we find one that's out of place, we just move it behind. Or we could do, okay, so here's why that won't work, I don't think, is because imagine you have like, oh, it's doing it again. I don't know why it's doing that. So imagine you have like three numbers or whatever. Four numbers. And you decide that, like, when you're right here, you decide that this one's out of place, and so you move it over here. Or I guess you'd move it to right here, right? But it may have been that this one needed to be before this one, so now this one's have to out of place. So do you then just start over? Like, is the brute force approach just to start over? Man, this is going to be. I'm sure there's a more elegant solution, but I feel like because the sample size is so small, right? Like, I mean, we only have like 100 of these, and none of them have more than 10 numbers, or I don't know, 20 numbers. Even if they only have like 50, like the solution, the brute force solution is like n squared. It's essentially like a, what is that sort called? Like a swap sort or something like that. Insertion sort. I think it's an insertion sort. Oh, it could be a bubble sort. That's an interesting one. Is you find a number and you bubble it up until it all the numbers before it are okay. Oh, is that what you do? I mean, we can try that. We just kind of bubble each number up. Do we want to keep track of the ones that failed? Why do I need to mutate the rules? I mean, sometimes this thing is not right. Okay, so but now I have my list of invalid, so we'll say like let. I don't know why it's doing that, but for pages and up in. Like that, and then we'll eventually print part two. But in here, um, so we're gonna bubble up the pages that are valid balance. We, for each element, we check previous elements to see if they are in the expect after. If they are, we swap. No, we don't swap. We insert the item before it. So we're gonna make a clone of the pages because we're gonna return that, and eventually we will return the middle page. So P2's that. What is the AI trying to do? Let's see. 4 pages iter enumerate expect after. So if we find one that there isn't a rule for, it's in the right place. Before in pages I expect after pages. For before in pages to I, if expect after contains before, let index equals page iter position before unwrap pages remove I pages insert. I mean that's why would we remove I? I think we actually want to have like a fixed pages, and now we're gonna do this. Let's see what it says. Like this part is still right. We're gonna see what we expect after, and then we're gonna go through the before pages, and if we find any of them that need to be before, fixed pages, remove I. I'm trying to consider why the AI thinks this will work. So you find any expect afters. If there's not, then we can just keep going because there's any of them can go before it. If it is though, then we're going to go through all the ones before it, starting at the beginning. And if we ever find one that is contained that it needs to go before, we're going to get the index. Oh, here's where I'm confused. It's finding where before is and removing it. No. Yeah, why is it doing that? Like what I would think is I'd want to remove um I mean this is almost not going to work anyway. You can see here it's like, hey, why are you borrowing immutable when it's immutable? It's because we have it up here. But I'm trying to understand why it would do this really quick. I mean, maybe it's not worth spending the effort to think why the AI thinks this is okay. Can I just do an insertion sort style thing? each page, I'm going to insert it into where it's valid in the existing array. Because I do think in Rust, I'm gonna struggle with this thing right here. I mean, essentially, this is what I am doing. I am doing an insertion sort, but so let's change this. We are going to start with a new empty array, and then we are going to add pages in the correct order from the invalid array. We do this by finding the pages that have to go after it and adding them. So what is it doing here? So we go through each page in the pages, and then we find out which ones have to come after it. And we say, while I is less than new pages lane, if expect after contains this break, otherwise we keep moving on. So basically, either we hit the end or we find one that it needs to come before, and then we insert it at that point. Let's try it. Panic. Oh. Okay. Solve it. One day I will get used to Windows. That's the right answer. Okay, and these don't take long to solve, right? Like they're solving in milliseconds. So there is a question of like, is it better? Is there something better than brute force? So just to be clear, what happens here on page 2, right? Is I'm going to start with an empty string of nothing, and then I'm going to start adding numbers. Obviously, if there's no numbers, I can just drop it in, right? But then basically what I do is I start moving down the tree until I find one that would cause the rule to break. And at that point and then I need to insert it right before there. So that's what this is doing, right? Is like I create a um right here. I was like, what? That doesn't look like anything. I was in part 1. So I have this new pages. I create like a new set of pages, and then I loop through all the existing pages, and I see if there's something. If I see, does it have a rule with it? And if it doesn't have a rule, then I can just push it at the end. I kind of skipped through that at the end. I don't know if you saw, but I got like a stack trace. Sorry, it's hard to see down here because all zoomed in. But if I get a stack, I got that stack trace, and it was because sometimes they aren't there. So if they're not there, I can just pop it on at the end, right? And then we can deal with it later. Um, that is to say, the ordering will deal with it later, right? It will find the place to do it. So that's an interesting question. Do you want to pop it at the front or the end? If it has no rules, I mean, I got the right answers. That's interesting. Does that mean like what would that imply? rules are circular, or that the rules are. Wow, is there something that goes back to? So, for example, I almost want to graph it out. Like what it implies is that the uh no, it's not that it's circular. It's that the ordering is like linear along the graph. Like there are branches, but the branches always go this way, right? And like the line follows those. So there might be some way. Like I guess what it's saying it because potentially you could put this at the beginning, and then because it doesn't matter, and then you do. Oh, I know. I had to. Never mind. I was overthinking this. The reason why you put it if you put it at the beginning, there may be other rules that count on it, right? That you've already placed, and so you always put it at the end because you know it's there's so far there's no it has no rules for itself, but it may have a rule that puts itself after something, so you always put it at the end. And then as you're inserting through, you find it. Okay, I overthought that a lot. You definitely want to put it at the end. Anyway, once you've found what you expect to go after, you just loop through all the new pages from, beginning to end. And if you ever find one in your list that you want in your list that would break the rule, you need to insert it at like that point. Otherwise, you keep incrementing, and then once you've gone all the way to the end, once you've found that position through this, you then just insert it at that point, and then we just do the same thing for part two. I wonder if we'll have to look and see if people have graphed it. So, some of the code looks ugly. I may do some of the refactoring stuff after the fact because I'd like to hear your comments. Like, how did you solve it? What would make it cleaner? Um, I could use the filter map on these with the OKs, I guess. So like that. Why is it not happy with that? Oh, option. I don't know how. Is it just like that then because it's already an option? Yeah, it looks like it. So like that, now I can just say, oh, I expect there to be one, and then otherwise I return this, and the fold does it. And I presume that still works. Yeah. Okay. So this syntax looks cleaner if you're familiar with Rust. I think I talked about that before. Um, I really don't like this. Okay, I mean, I feel like that's okay. I'll definitely do some refactoring based on your comments. Let's see here. Yeah, okay. I mean, I brute forced it as well, so I guess I'm in this camp. I wonder what the complexities are that I missed. Okay, there were cycles. Interesting. Is my solution wrong? No, there must be a bug in the AOC. Yeah, it's almost. Oh, is this from a previous day? It's almost always never the case that it's AOC. There actually have been times when the servers were down or something like that, and people were getting bad requests. I wrote this entirely inside my. You can't use BOGO sort. It has an average complexity of ON squared. BOGO sort? Oh, is this the dumb one where it's just you shuffle it until yeah, you just shuffle it until you find it. The right answer? Okay. I did not use I basically used an insertion sort though. So like I should probably know that. We're going to start with the MG. This is essentially an insertion sort where the sort order is maintained by the rules. Yeah, I'm essentially doing an insertion sort here. I'm just doing it by the rules. And so in this case, the irony is like insertion sort is pretty fast. Okay. Here's the BOGO sort. Did that I wonder if the BOGO sort actually works on this. Huh. That's why I remote my solution so it's fast. I'm genius. Why is my okay? I mean, I didn't even think of just shuffling it. That's really interesting. As opposed to shuffling it, you could just. I mean, I think you could go back to the swap. I don't know what that is. Ooh, this is a cool visualization. Hmm. I don't know. This is like an interesting question. Is like, do you use AI for these things? I actually, I mean, the reality is if you aren't using AI, especially in your daily work, you're not being as effective as you can, and you can use that effectiveness however you want, right? If you can get 8 hours of work done in 4 hours, at least for the time being, I mean, what you do with those other 4 hours is your business, right? That's my motto. I mean, you could see the AI for my part was like solving a lot of it for me. Uh, there were many pages when it got it wrong and left me confused. So I've actually found the best way to do it is to kind of like talk through it like this, and so if it sees how I'm doing it, it maybe gets it right, and then I can just fix a few things afterwards. Um, way that I've always treated AI, and I don't feel bad about this, is like AI is your coding assistant, and pretend he's your junior engineer that you're in charge of, right? So he writes the code, you read it, you review it, you test it, and make sure it's okay. And I've taken that approach, and so sometimes it solves big chunks of it, and so I just read through it and see, does that seem right? And if it does, then I'm okay with it. It's not. I will admit it's not as fun here, but because the problem is like these first days it can like solve the whole chunk, right? Like it basically solved this whole chunk, and so maybe you say to yourself, "Oh, that's not really fair." How you just let it solve it. So did you actually solve part two? I mean, I had kind of figured it out, right? I didn't call it an insertion sort, but I had figured out what I wanted it to do, and so it's just a question of can I go from what's in my mind to the page, and the AI helped me do that. I think if you I mean, it sounds like maybe what some of these people are doing are just straight up. Oh yeah, they're literally copying and pasting the problem and solution, and then they are having it write the code. So that doesn't seem like it's fun to me, right? I mean, it might be fun to ask like Claude or whatever afterwards. I actually, it's funny. So in VS Code, it uses Chat GPT. In Linux, I used Olama to like help me do stuff, and I could switch between like Chat GPT, um, or I could use some of the Olama models, or Claude. And I actually really like Claude. I think Claude actually does the best. Cloud, I don't know what you call it, Claude. And I mean, this one just uses Chat GPT, but it seems to be doing okay so far. But this does feel like it's cheating, where it's literally just here's what I sent to Claude and here's the answer it gave me. Okay, so what should I say? Cheating? I mean, the leaderboard is all just it's not like someone's winning money off of this, right? Maybe they get clout, but it's not like they're winning money off of it. So it doesn't make it fun. You can make your own private leaderboards with your friends, and then you know, set your own rules, have gentlemanly agreements, not to just let the LLM do it. I guess I agree that I think just copy and pasting the problem and sending it to an AI probably goes against the spirit of Advent of Code. The reason I like Advent of Code is because it helps me like hone my skills. And so if that's not happening, then maybe you're not using it correctly. And so I mean, I'm sure there's people out there where they'll say, "Oh, you use too much AI," and to each his own. Maybe I did in some degrees. So we'll see. Reading is overrated. Skipping over the rules and being lucky that the input was nice. Actually, reading the rules and having you think. What rules were we skipping? People don't like brute force. So here's a trick for Advent of Code. If you really like Advent of Code, the first several days are just brute force. And every once in a while you'll say like, "Oh, that I can solve that with um a BFS or whatever." And that's fine. But most of the days are like this. Think about the complexity, and this is what I would argue is if you say brute force is never the answer, or you're arguing against brute force, ask yourself why you haven't considered the complexity of the subject, right? We have a finite set of rules and a finite set of numbers, and we're just kind of iterating through those numbers. Believe it or not, for small enough arrays, an insertion sort or very simple sort, maybe not insertion, but a very simple sort is often faster than the more complex ones. And the reason is doing things like partitioning and the rotates and stuff like that can be memory intensive when it's easier just to like, use simple CPU instructions to like mutate arrays and stuff like that. So sometimes it's okay to just brute force it until it doesn't work. and then look for another solution. I mean, that's what we all do at work, right? Almost every day at work, you're just like, okay, I have a list of things that a list of steps in this algorithm I need to write. I'm just going to write them out. And then you run it through some tests, and whoa, it doesn't perform very well. And so then you start thinking about it. Now you can start thinking about performance, right? Wait until you've done the brute force solution. The input 1, 2, 2, 3. 3, 1, 2 has a unique solution. The only correct ordering is 1, 2, 3. But a sort algorithm that takes the non-transitive relation as an order could conclude that 3, 1, 2 is a valid sort if you treat incomparable as equal. Oh, so because these. Yeah, I don't think this is the case. This this 3 is not in the correct position. It has to go after a 2. So the 3 has to go over here. And the 1 has to go before the 2. You would never conclude that 3 you'd never conclude 3, 1, 2. I don't know what he's coming up with that point. Okay, well, just a couple more minutes on this reading this up. Let's actually look at some people's code. Each page, okay, let's see. Oh, that's an awesome way to do it. He goes through all of them, and if it contains a bar or a pipe, it goes into the rules, and if it contains a comma, it goes into the updates. That's kind of fun. That would fix my stupid /r/n problem. CRLF. Okay, check order. Ordering, reorder. It looks like he's using like a. Let me go look. Some kind of. What is this update set? I mean, I know it's a set. I guess I don't know enough about Python. Is this some kind of join? It is, yeah. So he's saying like he's just doing a like a union of all the ones before and the update set, and if there's any that don't match, then he has to like it's out of order. Okay. I mean that's just a it does look like he's just using brute force, so there's nothing crazy about this. I always like to search for the Rust ones too. Parse input. How does he parse his input? Split once. Ooh, this is an interesting one. Split once. What does that do? Where is this split once? Okay, very cool. Very, 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 very cool. Split once. Okay, I kind of want to fix mine to do that. I don't even think I need to trim anymore, potentially. I could spell correct too, and that might help. Oh, I just have two, so I can just say what did I call the other one? Updates. And then I can do rules and then updates like that. Unwrap it. Just give it to me. I still have to do the /r/n. Man, I don't know why that won't work. But that seems cleaner than what I had done before. That's really cool. Split once. Okay, I had no idea about that. So that's a cool one. And he's just doing a hash map and a vec. So for I presume he's doing similar things. Process page numbers. Go through all the pages. Go through, look for rules. Okay, he used if let sum. So here's an interesting thing about if let sum that I don't always like. So you can see it right here and right here. You now have like 2 layers deep of like blocks of code, right? And it's not necessarily a bad thing, but it is a reason why I tend to prefer something like this because it reads more linear, but to each his own. If let sum is definitely a thing. So he gets the rules and then others. Where are others coming from? If let some others rules get. Oh, yeah, yeah. Okay, and then he's just getting the position of each of these others, and if it's greater than, or sorry, if this position is greater than any of the other ones previously, it goes through it. I don't think this. I mean, this is essentially doing the same thing that I'm doing. I don't think it nets you any speed to do it this way. Like you still are basically like enumerating through all the items before. Page numbers. In fact, this one's potentially slower because it could find them after. It will find one, but it could find one after and then do that. So it's actually going to find all of them, right? It just finds the first bad one. Anyway, yeah, this is pretty close to mine. And then for part two, oh, he just calls the process page numbers, and if it's a valid one, then he returns 0. So now keep swapping until part 1 works. Right, this may have a similar effect. So, like, what he's doing, or what they are doing, is going through each of they're basically doing the same thing as part one. Is like you go through each of the items, and then you go through each of the rules, and you ask yourself, are there, where in the rule is it out of, where are any of the numbers out of order, any of the numbers from the rules out of order with the current one I'm on? And if it is, I'm going to swap them. And then he's just going to keep doing that, right? Which is kind of what I was thinking at first I did. For some reason, I didn't think that would work, though. Why didn't I think that would work? Maybe just the rules were simple enough that it does work. Is like the swap is enough to fix it. Because then you go to the next one. As long as you're going this way, if you're swapping ones forward, and then you move. Okay, so here's the one that I don't have it anymore. The one that I was worried about is like if you do a swap, but then it that one gets swapped before one that already is. So that one gets swapped up, and this one goes back. But now that one's out of place. Oh no, that would never happen. You'd have, if you swapped these, they're now in the right order, and this one will get eventually come back to it and get pushed back to its right position. So this has the effect of like the levels. I think I had that in my. If you can think about like there's certain levels of numbers, right? As the graph, there's like some numbers that are at level 0, they have to come first, some numbers that are at level 1, and so on and so forth. This has the effect of like pushing those in, right? Okay. And again, this leads me to believe that there is some like linearity to the numbers. Like, even though they branch, there's a lot of numbers that come after. Like, there's a 97, and then there's like a lot of things that have to come after the 97. That like um any page rule has to follows exactly one path, and it doesn't, like, it never branches. The reason why it could never branch is because you could then potentially do them in multiple orders, right? Or at least if they do branch, they come back together, would be the way to think about it. If there's ever a branch, it comes immediately back together. So there's some very linearity to it, because if you could ever swap numbers in the middle of a, like, think if you have 5 arrays, if the inner 3 could be swapped in any order, then it means that the middle number would never be correct. So that was actually, now that I think about it, this may have been a hint where it says like, can you find the middle number? The fact that you're trying to find the middle number suggests that once you order these, there will be order to it, right? Like, once you get a valid solution, it will be in the correct order. Because if it ever wasn't in the correct order, because if there were ever multiple, how do I say this? There must be exactly one solution to this problem, because if there was more than one solution, for example, if you could like switch the 47 and 29, your algorithm could potentially put the 29 here and the 47 here, and then you would be off. So this was and I actually didn't see it. We just got lucky that we could brute force it. But the fact that you're looking for the middle page numbers suggests that there is some order to this, and I just didn't see that hint. So that's always something to look out for when you're doing these problems. Is does the way you answer or solve the problem give you some key indicator? So there was, I mean, we went through and looked at a lot of these solutions, people talking about smart analysis of the problem, running into issues with cycles and stuff like that. Like, you can almost eliminate this, because you can say to yourself, if you had seen this part of it, right? If you had seen this hint, seen this as a hint, which I didn't get either. So just to be clear, it's not like I'm suddenly smarter than these guys. But if you had seen this, if you had seen that the order here matters, that it actually, there has to be a correct value in the middle, you'd know that, oh, I'm basically just going to sort these, but my sort is now going to be based on the the rules, as opposed to just like a straight up integer sort. Okay, I don't know. Should we end with one more meme? On squared on log n. No, on factor. Okay, this is another BOGO sort thing. Me on my one is to understand the page ordering. I'll have to. I almost want to look at the rule set. The input graph was cyclic, and every node was in a cycle. Brute force both parts without considering transitive dependencies, and hence no graph in 6 minutes. I don't know what they're talking about here. When the input graph was cyclic and every node was in a cycle, the description said that the rules regarding the non-present values are to be ignored. You can say that every query operates on a subgraph of the rules, which so happen to be a DAG in every test case. Did I miss something even more and I just stumbled upon? Oh, this part. The ordering rules involving those missing page numbers are ignored. You just tack them on the end, right? It just doesn't matter. I don't know that that helps you. That's an interesting. I'll have to think about that part more. Okay. Some people are really analyzing the input. Yep, that's the input all right. It is not a directed acyclical graph. See, I don't think you have to do a graph. Yeah, nothing is necessary beyond sorting. This is correct. You don't need to think of it as a graph. I mean, I started thinking about it as a graph and realized it wouldn't work, right? And this is the thing is like I think you have to in this the way that I wish I had that thing again, but you quickly realize that the graph is not going to work. Okay, let's see what this guy does. Very interesting. Realizing what you're going to need to do in part two. Okay. Yeah, I guess you could have inferred that. This actually does happen quite a bit. Is like many of the Advent of Code days are there's a whole bunch of them that are messed up. Find the ones that are right. Or there's a whole bunch of items. Find the ones that are right. And then it's usually like fix the ones that are wrong, or do something with the wrong ones, something like that. Okay. This is really some of the days are really whoa. The ring in the rules. Interesting. Okay. Well, I think that's enough. Here's my solution. I'll post it. I think we got there. Um and I think we got I can definitely do some refining, but again, I think the solution today too is just brute force it and you'll be fine. So there you go. We'll be back for day 6. I'd love to see your solutions. So post them down below, or you can fork my gist and put them there. So see you later.